this is a Kalpana. In this video, we are going to evaluate two problems on definite integrals using property integral a to b f of x dx equals to integral a to b f of a plus b minus x into dx. Okay, first one, evaluate integral 0 to pi by 2 root sin x by root sin x plus cos x into dx. Okay, solution. Let I equals to integral 0 to pi by 2 to root over sin x by root sin x plus root cos x into dx. Consider it as equation 1. Okay. So here we are going to use the property integral a to b f of x dx is equals to integral a to b f of a plus b minus x into dx. Okay. In the place of a you are having 0 and in the place of b you are having pi by 2. A equals to 0 and b equals to pi by 2. Also you are having f of x equals to root sin x by root sin x plus root cos x. Okay. So now we have to replace with a plus b minus x. If f of x is equals to this one, then f of a plus b, that is 0 plus pi by 2 minus x, which is equals to f of pi by 2 minus x is equals to root over, replace x with pi by 2 minus x, that is sine pi by 2 minus x by root over sine pi by 2 minus x plus root over cos pi by 2 minus x. Okay. Okay. If f of x is this one, then f of pi minus 2, pi by 2 minus x is this one. Okay. Now, we are using this formula. So, this equals to integral 0 to pi by 2. Since this is f of x, which is equals to integral a to b f of a plus b minus x, which is f of pi by 2 minus x, which is equals to root over sine pi by 2 minus x by root over sine pi by 2 minus x plus root over cos pi by 2 minus x into dx. Okay. Since we know that sine pi by 2 minus theta is equals to cos theta and cos pi by 2 minus theta is equals to sine theta, we will replace sine pi by 2 minus x with cos x and cos pi by 2 minus x with sine x. Okay. So this equals to I equals to integral 0 to pi by 2 into root over cos x by root cos x plus root sin x into dx. Consider as equation 2. So this is your equation 1 and this is your equation 2. Now what we are going to do is, we are going to add 1 and 2. Okay. Now adding 1 and 2 gives, so this is your 1. Now I am writing 2. Integral 0 to pi by 2 root over cos x by root over cos x plus root over sin x into dx. I plus I is 2i, which is equals to integral 0 to pi by 2, integral 0 to pi by 2 root over sin x by root sin x plus root over cos x into dx plus 0 to pi by 2 root cos x by root cos x plus root sin x into dx. This can also be written as 2i equals to integral 0 to pi by 2 root sin x by root sin x plus root cos x plus root cos x by root cos x plus root sin x into dx. Okay. So here you are having the denominator same. So you'll get LCM root sin x plus root cos x, and in the numerator sin x plus root cos x into dx. Root sin x plus root cos x and root sin x plus root cos x gets cancelled. So this equals to integral 0 to pi by 2 into 1 dx, which is dx. So this equals to x. Then the limits x equals to 0 to pi by 2. Now apply the limits. Upper limit pi by 2 minus lower limit 0. So this equals to pi by 2. So we got 2y equals to pi by 2. So this implies I equals to pi by 2 into 2. So this equals to pi by 4. So this is the answer. So therefore, integral 0 to pi by 2 root sin x by root sin x plus root cos x into dx is equals to pi by 4. This completes the first problem. Okay. Next going to the second one. Second one, evaluate integral 0 to pi by 2 a sin x plus b cos x by sin x plus cos x into dx. Okay. Solution. Let I equals to integral 0 to pi by 2 into a sin x plus b cos x by sin x plus cos x into dx. Okay. So now we are going to use the property integral a to b f of x dx is equals to integral a to b f of a plus b minus x into dx. Okay. So if you compare these two, in the place of a you are having 0 and in the place of b you are having pi by 2 and in the place of f of x you are having a sin x plus b cos x by sin a plus b. A equals to 0, b equals to pi by 2 and f of x equals to a sin x plus b cos x by sin x plus cos x. Okay. So now we need f of a plus b minus x. A plus b minus x, which is equals to 0 plus pi by 2 minus x. This is equals to pi by 2 minus x. So you need f of pi by 2 minus x. Now replace x with pi by 2 minus x. So this equals to a sin pi by 2 minus x plus b cos pi by 2 minus x by sin of pi by 2 minus x plus cos of pi by 2 minus x. Okay. Consider it as equation 1. So this implies I equals to integral 0 to pi by 2 integral integral a to b f of x dx equals to integral a to b f of a plus b minus x dx. So this equals to integral a to b f of a plus b minus x, which is f of pi by 2 minus x, that is a sin pi by 2 minus x plus cos plus b cos. B into cos pi by 2 minus x by sin pi by 2 minus x plus cos pi by 2 minus x into dx. Okay. Now consider since we know that sin pi by 2 minus theta is equals to cos theta and cos pi by 2 minus theta equals to sin theta. So you can replace sin pi by 2 minus x with cos x and cos pi by 2 minus x with sin x. So this equals to integral 0 to pi by 2 into a into cos x plus b into sin x divided by cos x plus sin x into dx. So consider it as equation 2. So now what we are going to do? We are going to add 1 and 2. Adding 1 and 2, we get I equals to integral 0 to pi by 2 a sin x plus b cos x by sin x plus cos x into dx and this is the 2, equation 2. So if you add these two, you'll get 2I equals to integral 0 to pi by 2 into a sin x plus b cos x by sin x plus cos x into dx plus integral 0 to pi by 2 into a cos x plus b sin x by cos x plus sin x into dx. Okay. This implies 2I equals to integral 0 to pi by 2 into a sin x plus b cos x by sin x plus cos x plus a cos x plus b sin x by cos x plus sin x into dx. Okay. Now take the LCM. So this equals to integral 0 to pi by 2 into sin x plus cos x. The numerator you will get a sin x plus b cos x plus a cos x plus b sin x. Since in the both the terms you are having the same denominator, so no need to add or multiply anything in the numerator. Okay. So this equals to a sin x and a cos x. If you consider these two, you can take a common, integral 0 to pi by 2 sin x plus cos x. If you take a common in these two terms, you'll get a into sin x plus cos x plus, again, if you consider these two terms, you can take b common. If you take b common, you'll get b into cos x plus sin x into dx. Okay. Cos x plus sin x can also be written as sin x plus cos x. Okay. Here also you are having sin x plus cos x, and here also you are having sin x plus cos x. So in these two terms you can take, you are having sin x plus cos x common. So you can take sin x plus cos x from this two terms as common. Okay. So this equals to integral 0 to pi by 2. I'm taking sin x plus cos x common from these two terms. So I'll get into a plus b by sin x plus cos x into dx. Here also you are having sin x plus cos x, and here also you are having sin x plus cos x. So both gets cancelled. So this equals to integral 0 to pi by 2 into a plus b into dx. Since a plus b is constant, so you can take it outside the integral. So this equals to a plus b into integral 0 to pi by 2 into dx. So this equals to a plus b into integral x. Sorry, integral dx is equals to x. Since integral dx equals to x, so you'll get x. So then the limits x equals to 0 to pi by 2. So this equals to a plus b into pi by 2 minus 0. So this equals to a plus b into pi by 2. Okay. So 2y equals to a plus b into pi by 2. This implies I equals to a plus b into pi by 2 into 1 by 2, which is equals to a plus b into pi by 4, or pi by 4 into a plus b. So this is the required answer. So therefore, integral 0 to pi by 2 a sin x plus b cos x by sin x plus cos x equals to cos x into dx equals to pi by 4 into a plus b. So this completes the problem. Fine. So this is all for now. Hope you all understood. If you have any doubts, just leave your comments below. See you in the next video. Until then, bye bye.